Okay, this is the first question of the review. It's a square root function. This is the parent function. Nothing was done to it, but it says it was shifted right 2 units and up 4 units. So you have your square root graph, and it was shifted right 2 units, so it's x minus 2, it's always opposite, and it went up 4. So if you graph it, it went right 2, up 4. This is your starting point, and it goes up 1 over 1, up 1 over 3, and it goes like that. If you guys want to, you can always plug in more numbers. So you can plug in, this is at x equals 3 right here. This is 4, this is 5. You can plug these numbers in here to get your exact point, okay? Your end behavior, you always write it like this. As x's go to the right, as they get bigger to infinity, your graph is also going up. So that's infinity. And it doesn't go to the left. X's don't go past 2. So there's no left end behavior. There's only a right end behavior. Okay, so that's your first one. Next one, you have a cubic graph. In your cubic graph, it typically looks like, well, it always looks like this. Let me write that better. It has a point in the center, a point here and here, and it goes like that. That's what your cubic graph looks like. However, this one was shifted left 5 units, and then it was reflected across the y-axis. Remember, if it's the y-axis, this will be inside of the parentheses, okay? So you have, it went left 5 units, so that would be x plus 5, and a negative, make sure it's inside of parentheses, and then it's cubed. So that's what your equation should look like. The negative is inside, not outside. Okay, now you can also distribute this. This would be negative x minus 5 cubed. You could also write it like this. So either way you write it is fine, okay? On this top one, you can clearly see the 2 transformations. You have the negative on the inside, which makes it reflect across the y-axis, and you have this part, which makes it go left 5, okay? All right, so your end behavior. I know it goes left 5, or no, it goes left 5. I'm gonna write that down. So that means my graph will be over here. 1, 2, 3, 4, 5. And you always have the 2 next to it. It'll look something like this. If you want the exact points, just plug in the numbers around here. All right, and normally it looks like this, but it's reflecting across the y-axis. So this side looks like this, and this side looks like this. So it goes like that, reflected across the y-axis. So your end behavior, as you go to the right, as your graph goes to the right. As it goes to the right, your graph is going down, so that's negative infinity. Let's do the other side. As your x values go to the left, to negative infinity. As you go this way, your graph is going up. So this should be a positive infinity. All right, next question. This is the quadratic. So that will look like this. That's the U-shaped graph. However, it was transformed. It went right 3 units, so that'll be at x minus 3. And it was vertically compressed by a factor of 1/3. If it's vertical, this is outside, okay? So that 1/3 will be outside. And then it's a squared function, it's squared. So you're gonna put a little 2 there. So that's your equation. So it went right 3, so this is where your graph is gonna be, and it didn't reflect, so it's still facing up. It'll look something like this. However, if we want exact points, just plug in numbers around 3. So for example, let's plug in a 4 or a 5 or a 6. You can plug in any of these numbers. I'm gonna plug in a 6. It doesn't matter which number you choose. So let's plug in a number. I'm gonna plug in a 6. 6 minus 3 is 3, so this is 1/3 3 squared. 3 squared is 9, and 1/3 of 9 is 3. You can put that in your calculator if you want. So when I plugged in a 6, I got out 3. So this side looks like this, and it's a mirror image on this side because it creates a U-shaped graph. So that's what your graph would look like, okay? Your end behavior. As your x values go to the right, your graph is going up. Your other end behavior, as x goes to negative infinity, the negative side, your graph is going up. So that's also infinity. So guys, when your power is even, your end behaviors have to match because they both go up or they both go down. And that's for any even graph. All even powers, a squared, or x to the 4th, or x to the 6th, they all look like a U-shaped graph, okay? All right, next page. This is a cubic graph, so it normally looks like this. However, it went down to, so this is your parent function. That's the original function. It went down to, and it was also reflected, and that's inside of parentheses, so that it reflected over the y-axis. So guys, this is the y-axis right here. That means this side is now looking like that. This side right here is now looking like that. It reflected across the y-axis, and then it went down too, so now it's down here. So that's what it would look like, and those are your transformations. This is a quadratic that's even, so it looks like this. However, it was moved, so this is the parent function. It went left 4, up 2, and it was a vertical stretch by 3. That 3 on the outside. All right, next one. So if you were to sketch this, it went left 4, up 2, so this is your vertex, and it was vertically stretched, so it'll look a lot narrower. Next one. This is a cubed root graph. This is a cubed root graph. This is your parent function right here. A cubed root looks like this. Okay, this is the cubed root graph. Okay, the cubed graph looks like this. This one's more vertical, this one's more horizontal. Okay, so we're looking at this one. Now to figure out the transformation, whenever you have a number on the x, you need to divide by that number. And that number will go outside. So the 3's cancel out, you're left with x minus 5/3. And let me just show you that this actually doesn't change the value, okay? 3 times x is still 3x. 3 times 5 is 15, and it's still being divided by 3. And 15 divided by 3 is 5. So you can get back to your original problem if you want to. We're just changing the format, okay? So this is what it looks like. And now you can easily see the transformation. You have a negative on the outside. That means it reflects over the x-axis. You have a 3 on the inside. This is inside of the square root symbol. So this is a horizontal, and you have to flip it. Horizontal compress by 1/3. You flip that number on the inside whenever it's inside. Okay, and it goes right 5/3. Okay. This one, it is even powered. That means it's going to be a U-shaped graph, but there's a negative in the front, so it actually is facing down. Okay, so your parent function is x to the 4th. However, you have a negative in the front, so that means it's reflecting over the x-axis. Oops. So it's reflecting over the x-axis. And this number right here, that's bigger than 1, so this is a vertical stretch by 3. Look at these separately. The negative makes it reflect face downward, and the 3 will make it stretch. All right, so those are all the graphing problems. Let's look at the direct variation and all of those type of problems. So m varies directly. That's this equation. Y equals k times x. However, in this case, instead of saying y varies, they're saying m varies. So it'll be m equals, this is your constant, you'll always have that. it varies directly with the cubed root. That looks like this, the cubed root of q. So the cubed root of q. And inversely, so inversely that means this is gonna be in the denominator. The square root, this is a square root of t. So the square root of t. So that's it. And remember, inverse, so this is the direct equation. And the inverse looks like this, y equals k divided by x. So that's why the square root of t was on the bottom in the denominator. All right, next one. The simple interest I on an investment is directly proportional. That's this equation. I equals k and then some variable. I is this value, it varies directly. So you're gonna have k times the amount of investment P. So this is your equation. I equals KP. P stands for the principal. That's how much you're investing. That's how much you're starting with. Okay, so you're investing $3,000. That's how much you're starting with. So that's gonna be 3,000. And you obtained an interest payment. Remember, interest is represented with I. An interest payment of 175. So this interest payment is 175. So all you have to do now is divide by 3,000. All right, when you get that, you get k equals, and let me grab a calculator. You're gonna do 175 divided by 3,000. And you get 0.05833. So that's your k value. So let me do my equation again. I equals k times p, but this time I know what k is. So I'm gonna erase this k and put 0.05833. This time it says you are investing this much to start with. You're not starting with 3,000, you're now starting with 5,000. How much interest will you make? So I'm gonna erase this p value. We're plugging in 5,275. So I'm gonna multiply 0.05833 with 5,275. And I got $307.71. You just multiply these two together. The intensity of light, I, received from a source varies inversely. So K is your constant and your next variable will be in the denominator. Varies inversely as the square of distance. So distance squared. So this is our equation. If the intensity of light is 7 foot candles, and this is just a measurement, foot candles, if you ever look at a light bulb, it'll tell you how many lumens it is, and lumens just tells you how much light is being emitted from the light bulb. So if you divide the lumens, which is on a light bulb, divided by the area of the space that you're trying to light up, that will give you foot candles, and that's just a measurement. Okay, so the intensity of light is 7 foot candles, so the intensity of light is 7 foot candles at 32 feet. This is the distance. So I'm going to erase D and put 32. Okay, so this is 7 equals K divided by 32 squared is 1,024. So K is being divided by 1,024, so the opposite is to multiply both sides by 1,024. And those cancel out. So 1,024 times 7 is 7,168. So that's what K is equal to. So I'm going to write the equation again. The intensity of light received from a source varies inversely as the square of distance from the source. So the square of the distance. This is our formula. And we just found out what K was. K is 7,168. Okay, so it says find the intensity of light at 11 feet. 11 feet, that is your new distance. So So I'm going to erase D for distance, and I'm going to plug in 11. So this simplifies to 7,168 divided by 11 squared is 121. So 7,168 divided by 121 is 59.2397. So this is the intensity.